Hello everyone, it's my pleasure to be a part of Women Developer Academy. The technical project I would like to present is Sentiment Analysis with BERT Language Model using TensorFlow. In this project, I would like to highlight two well-known machine learning and NLP frameworks, TensorFlow and Hugging Face. TensorFlow is a free and open source software library for machine learning developed by Google AI Research Lab. Hugging Face provides ready-to-use pre-trained language models and datasets for state-of-the-art NLP technologies. Before starting my presentation, I would like to introduce myself. I am a PhD candidate from Prince of Songkhla University, Thailand. I was born and raised in Yangon, Myanmar. I have experience in developing NLP models such as task classification and keyword extraction for Burmese language. Burmese language is one of the low-resource languages in NLP, and a few works have been done on it due to the lack of publicly available benchmark datasets. So in this presentation, there will be three main parts. The first part will be Introduction to Sentiment Analysis, followed by the BERT language model. Finally, I will show how you can achieve sentiment analysis tests with BERT language model using TensorFlow framework. I think all of you are familiar with sentiment analysis. It is about analyzing the people's feelings and opinions. With the enormous increase of user-generated content on social media and web, people tend to share their opinions and thoughts on a particular topic, such as a product, a movie, a restaurant, or even a political topic. Sentiment analysis has been a popular research area in NLP field for most of the languages used on internet and have widely applied in many areas from marketing to politics. In natural language processing, sentiment analysis is analyzing and identifying a person's opinion within a given text across blogs, social media, and forums. This test is treated as supervised text classification mostly, while some of the previous work solved this problem by clustering or regression. The person's opinion can be generally categorized into three classes: positive, negative, and neutral. State-of-the-art NLP technology for sentiment analysis can help exponentially growing and structured user-generated content to transform into insightful structured data. For example, a mobile phone company wants to know the customer sentiment on a brand new phone, or a restaurant owner wants to track the customer feeling in the new menu changes. By capturing the customer who feels strongly negative towards your product or service, customer service can deal with their issues specifically. I believe you have heard of BERT if you are working on machine learning and NLP. It is a contextual pre-trained language model based on the transformer architecture. The language model delivers a good enough understanding of complex human language. Pre-trained NLP models code like humans and can be deployed much faster using reasonable computational resources. BERT is one of the contextual language models, and I will explain about its details in the next slides. The pre-trained model can then be fine-tuned on small data NLP tests like question answering and sentiment analysis. This results in substantial accuracy improvements compared to training on this dataset from scratch. BERT stands for Bidirectional Encoder Representation from Transformers. It was developed by Google in 2018 and made publicly available. BERT is based on transformer architecture. Transformer architecture has an encoder and decoder stack. That's why it is called encoder-decoder architecture. But BERT is just an encoder stack or transformer architecture. It was trained on English Wikipedia and book corpus and achieved the best accuracies for some of the NLP tests. After pre-training in an unsupervised way on a massive amount of test data, the model can be rapidly fine-tuned on a specific downstream test, such as task classification, name entity recognition, and question and answering with relatively few labels, because the general linguistic patterns have been learned during pre-training. There are two variants of BERT model, BERT base and BERT large, which differ in architecture complexity. BERT big model has 12 layers in the encoder, whereas the BERT large model has 24 layers. Recently, Google released multilingual BERT model that covers 104 languages, including low-resource languages from South Asia regions. BERT key technical innovation is applying the bidirectional training or transformer, a popular attention model, to language modeling. BERT makes use of transformer, an attention mechanism that learns contextual relation between words or sub-words in the text. Transformer includes two separate mechanisms: an encoder that reads the text input and a decoder that produces a prediction for the text. Transformer encoder reads the entire sequence of words at once, therefore it is considered bidirectional, though it would be accurately to say that it is non-directional. This characteristic allows the model to learn the context of a word based on all of its surroundings. BERT is trained with two training strategies: mixed language model and next sentence prediction. In mixed language model training, the model attempts to predict the original value of the matched words based on the contents provided by the other non-matched words in the sequence. In next sentence prediction, the model receives pairs of sentences as input and learns to predict if the second sentence in the pair is the subsequent sentence in the original document. During training, 50% of the inputs are a pair in which the second sentence is the subsequent sentence in the original document, while the other 50%, a random sentence from the corpus, is chosen as the second sentence. The assumption is that the random sentence will be disconnected from the first sentence during training. BERT can be used for a wide variety of languages while only adding a small layer to the core model. The model is pre-trained using self-supervising learning on a massive amount of corpus, and then downstream application can obtain the hyperparameters stored in the pre-training state without learning from scratch again. This is known as transfer learning. In the fine-tuning training, most hyperparameters stay the same as in BERT training, except the final layer. As we can see in the picture, after training BERT model on a large English corpus, it can be used in a downstream spam classifier test by adding a classification layer on top of the BERT model. Only the hyperparameters of the classification layer is fine-tuned. In this session, we will learn about Hugging Face library, which is an open source framework to build, train, and deploy state-of-the-art NLP models. Hugging Face hosts the pre-trained models and dataset on its platform so that researchers and engineers can easily use them. Hugging Face is compatible with popular machine learning frameworks such as PyTorch and TensorFlow. State-of-the-art NLP models can be easily called via transformers, which can greatly reduce computational costs and your time. Benchmark datasets are also hosted on Hugging Face that support reproducible research for NLP practitioners and academic researchers. These models can be applied in various tasks, including image and audio processing. I also contributed to Hugging Face by sharing Burmese new dataset, which is used in my master thesis research. This is the only Burmese dataset hosted on Hugging Face. I would like to encourage all of you to share your works too. So as the part of final presentation, we will look how to implement sentiment analysis with BERT using TensorFlow. For this session, I would like to recommend to use Kaggle Notebook. Kaggle is a subsidiary of Google and community for data scientists and AI researchers. They can participate in data science competitions and share their notebooks on this platform. You can access my Kaggle Notebook from this link. Firstly, we need to install Transformer library. It can be easily done by running pip command. After the installation is completed, we will load the pre-trained BERT tokenizer and sequence classifier, as well as input example and input features. Then, we will build our own model with the sequence classifier and our tokenizer with BERT tokenizer, which uses word-based algorithm for tokenizing the input. Tokenization is another interesting research problem in NLP, and you can research about it yourself if you are interested. I won't cover about it in detail in my presentation due to the time limitation. The details of the model can be seen by the model.summary command. Now we have the main BERT model, a dropout layer to prevent overfitting, and finally a dense layer for classification tests. In the next step, we will create our input sequence from the IMDB review dataset. IMDB review dataset is a large movie review dataset collected from the popular movie rating service IMDB. The IMDB review dataset is used for binary sentiment classification, whether a review is positive or negative. It contains 25,000 movie reviews for training and 25,000 for testing. All the 50,000 reviews are labeled data that may be used for supervised deep learning. Then we can download the dataset from Stanford Relevant Directory with Tensorflow getFind function as shown in the figure. There is an additional 50,000 unlabeled review that we will not use in this case study, so we need to remove that. Now we will split the data into train and validation set. This operation can be done by test dataset from directory API. 20,000 files will be used for model training and validation will be done on 5,000 files. Now we have our basis train and validation datasets. We need to prepare them to fit to the BERT model. To make it more comprehensible, I create a pandas data frame from our TensorFlow dataset object. We have two pandas data frame objects waiting for us to convert them into suitable objects for the BERT model. We will take advantage of the input example function that help us to create sequence from our dataset. We have two functions, convert data to examples. This function accepts our train and test dataset and convert each row into an input example object. The second function is convert example to TF dataset. This function tokenizes the input example objects, then create the required input format with the tokenized object. Finally, create an input dataset so we can feed to the model. Our dataset containing process input sequence are now ready to be fed to the model. Now we can start the fine-tuning process. We will use ADAM as our optimizer, categorical cross entropy as our loss function, and sparse categorical accuracy as our accuracy metric. Fine-tuning the model for two approach will give us around 97% accuracy on training dataset and 88% on validation. Training the model might take a while, so please make sure you enable the GPU acceleration from the Kaggle notebook setting. After our training is completed, we can move on to the next step, which is making sentiment predictions. We have two movie reviews. The first one is positive and the second one is negative. We need to tokenize our review with our pre-trained BERT tokenizer. We will then feed this tokenized sequence to our model and run a final software layer to get the predictions. We can then use the ultimate function to determine whether our sentiment prediction for the review is positive or negative. Finally, we will print out the results with a simple for loop. Congratulations! Now we have successfully built a transformer network with a pre-trained BERT model on the sentiment analysis of the IMDB review dataset. So these are the references I used for this presentation, and you can look at them for detailed information. Thank you for your paid attention and feel free to share your thoughts on my presentation.